Hey guys, how you doing today? It's Mukhtar Surumi, the math expert, here today to support you. Okay, so first things first, let's look at this. We have a question here, and it's essentially a speed question which is given in vectors. I prefer to write my vectors like this. However, you can write it this way as well and not be in trouble. So we're going to do it with both ways, okay? First off, the normal way they've done it, right? We're going to do question A. Find the speed of P at time equals T 2 seconds. It's a 2 marker, so which means we're not meant to use too much brain power here. So I'm just going to sub 2 in. So the first one is V equals 3 times, 2 squared I minus 6 2 to the power of a half J. Remember, this is vectors, I and J. So we can't just we can't ignore the I and J's and just do the equation and put it together. So this is definitely going to give 12I minus 6 root 2J. We should know by now that in order to find the full speed, the real number of the speed, not the vector form, the real magnitude of the speed, we've got to use the magnitude equation. How do you convert a vector to a magnitude? Well, we should know this. The magnitude of V is actually going to be the I number, what's in front of the I squared. So that's going to be 12 squared. What's in front of the J squared? Okay, I'm going to add it. Minus 6 root 2 squared, all square rooted. All right, and that's going to give you the square root of 144 plus 6 squared is 36, root 2 squared is 2. So we're going to add, let me just make sure I'm correct saying this. That's absolutely correct. We're going to do add 72 to this, okay? When you do that, you're going to get your answer as 216. That is the answer I get. Okay? Root 216. Similar to using it the other way as well, it's actually just absolute the same thing, right? I would have just simply done V equals 3 of 2 squared minus 6, 2 to the power of a half. I would have simply gotten 12 up top and minus 6 root 2 at the bottom. And then I would have applied the same formula to get the magnitude of V, right? And I would have just done 12 squared plus minus 6 root 2 all squared, which would have given me square root of 216. Okay? It's a velocity, and it's giving it to us in meters per second. So I want us to make sure we always put our units in. Okay? So that's question 1 all done. Now, I'm going to clear my page, and we're going to go to do question 1B. Okay? Actually, I'm going to do question 1B just underneath. Give me a second, guys. Let me just review it. Nope, I'm going to do question B and C together. I'm going to clear the page. So that's question 1A, all done. Let me just label that 1A. That's it, all done. Okay, so now we're going to do question 1B. Right, question 1B. Find an expression in terms of t, I, and j for the acceleration of p at time t seconds where t is greater than 0. Okay, so you're wondering, how do we do that? Well, I know the relationship between velocity, acceleration, and displacement. Always remember this, okay? The first level of the equation is s, right? If you do ds over dt, the second level gives you the velocity, and then the third level lower, so they're all derivatives of each other. dv over dt equals acceleration, right? So going downwards, you differentiate, yeah, that seems to spell good enough. And I'm going to put WRT, that means with respect to time. And if you want to go back upwards, aka you want to go from acceleration to velocity to thing, you integrate with respect to time. Right. So, therefore, how are we going to do this? It wants to know some acceleration. Well, I know dv... Oh, that's wrong. That's dv over dt would equal the acceleration which therefore is going to give us, if we take the original equation, I'm going to put it on top here, just to make sure I have it in front of me so I make absolute no errors, okay? It's going to therefore give us 6ti minus a half times 6 is 3t to the power of minus a half j, okay? Well, that's good so far. It asks for an expression. This looks like an expression to me. So therefore, the answer to B is simply 6ti minus 3t to the minus a half j. And then for everyone in the back who's probably thinking, oh, okay, no, it's confusing me with the I and j's. Well, we can actually do it in the other form, which we write, and I like writing vectors in, because I don't see j's and i's confusing me, right? And I just go dv over dt equals, okay, 6t minus 3t to the power of minus a half. And that's also the acceleration, because dv over dt equals the acceleration, right? And therefore, we're just going to put the acceleration equals 6t minus 3t to the power of minus a half. Right. For A-level purposes, because they give you an I and J, I will always write my final answer in I and J, just to let you know. But this is really useful for working without the I and J, but it's super easy to put it back in I and J. As remember, the top row is the I and the bottom row is the J. Right, really good job. Let's do the final question here. I'm going to clear my page again, which is the 1C, which is to actually find the position vector P. That seems like we're going to go the other way. We're going to try and find S, position vector, which is the displacement, right? And remember the relationship we said, right? S to V, you do ds over dt. V to A, you do dv over dt. So now we have V over here. V equals 3t squared I minus 6t to the half j. And we now need to go back upwards towards S, the position vector. S is displacement, that's what we use in mechanics. Well, we need to integrate, remember? Therefore, it's going to be the integral of V with respect to dt. It's going to give us, well, the displacement or the position vector. So I'm going to work on that right now. 3t squared minus 6t to the power of a half. Okay, integrated is going to give us, we'll add 1 to the power, take away the new power. That's 3t. I've removed the i's and j's for now, but I'm actually just pop it back in there so we don't get confused at all. I minus, okay, we add 1 to the power and then do that. That's going to be, it'll be 6 divided by 3 over 2, which is correct, which is definitely going to be 4t to the power of 3 over 2. And we're obviously going to add c. Okay, so look, they've given us a little bit of information. To me, that little bit of information is to find c. And now this is where it all gets messy. And I am not going to work in i's and j's anymore, okay? Oh, I forgot my j there. My i's and j's anymore. I'm going to flip it around because it makes so much more sense. So what am I going to put, right? The position vector of P. I'm just going to call it P equals, right? And I'm going to absolutely do it the way I like doing it, which is t cubed minus 4t to the 3 over 2. Remember, the top is I and the bottom line is j, plus c. Well, they said that at time t equals 4 seconds, the position vector is minus I minus 4j, right? We obviously know that I minus 4j, because there's an invisible 1 in front of the I, we can write it as 1 minus 4. All right? And then we're going to go back into here and put it into P, because they said that the position vector of P at t equals 4 seconds is I minus 4j. So we're going to replace P, right? So this is going to go into P, right? So P is going to become 1 minus 4. We know t equals 4 seconds. So therefore, I'm going to substitute 4 in here. So that's going to be 4 cubed minus 4 to the 3 over 2 plus c. then that's going to become 1 minus 4 equals, I'm going to scroll up a little bit, guys, so we can have more to write. My 4 is going to equal 4 cubed, we know is 64. 4 to the 3 over 2. I'm going to square root the 4 first, which gives 2. Then times 8, that's minus 32. Okay? And that's plus c, right? But I want to find out c, so I'm going to move everything to the other side. And you're going to get, you're going to get something not too disfamiliar. You're going to get 1 minus 64 minus 4 plus 32 equals c. I simply move that vector to the other side, right? And then that gives minus 63 plus 26 plus 28, okay, equals c. Right, but we're not done yet. We've got to put it back into the equation and solve it for 1 second as they asked for, right? So what I'm going to do is I'm going to draw the mucky line, the mucky blue line here, and we're going to carry on working over here. Brilliant, guys. Now, what are we going to do? So, P equals, we got the answers t cubed minus 4t3 over 2. Remember, top is I and bottom is j. And we're just going to simply put plus c, which is, well, minus 63 and 28, right? They said at 1 second. Well, when t equals 1, p is going to equal 1 minus 4 plus minus 63 and 28. And therefore, p is going to give, right, minus 62 plus 24. And that is the position vector of p, right? I'm going to write it as I and j just because A levels, and we're going to finish it off as that, 24j. Well, that's a super masterclass on how to do a simple position vector mechanics question which takes into account displacement, acceleration, and velocity. Any further information, please contact me on my website or drop me a DM, and I can always support in some one-to-one tutoring. Thank you very much. Goodbye.